Welcome to Abby's Sound Lab, where today I will be showing you some crazy lab stuff with sound. It's going to be absolutely badonkadonk. So, to give you context, all I'm going to say is I have a bowl with saran wrap on top, and it's a very tight saran wrap. It doesn't bow very easily. It's just very, very tight. And then I have some sprinkles on top to help you show what's going on. And they're colorful too, so it's a lot easier to see. So I'm just gonna go right into it and I'll explain it after. Okay, so I'm just going to start by explaining what sound waves are. Sound waves are vibrations that go through the air by hitting air molecules that bump across each other. They keep bumping and bumping and bumping into each other until they eventually get to our ears and make the sounds that you hear right now, hearing me even just speak. So these vibrations are sometimes easy to see and sometimes really difficult to see. You can see them when you pluck a rubber band, right? Because the rubber band vibrates all over the place, but you don't see it when you knock on a door, right? So if I were to knock on this countertop right now, you don't see it going woo, right? It's solid, stays how it is. So if these vibrations are causing sound, this also means that sounds can cause vibrations, right? It goes both ways. And this is what allows us to hear. So our ears have membranes, and the way that I showcase these membranes is the bowl with the saran wrap. The saran wrap is technically our membrane. And the sprinkles are just for us to see what's happening. So when vibrating air molecules hit the membrane, they cause the membrane to vibrate, which are converted into electrical signals for our brain to interpret, there we go, into basically words, sounds that we can understand, those kind of things. So I made this membrane that is basically similar to our eardrum. And depending on the size, shape, material that you use, it can be affected differently. I did the same thing with a smaller bowl, and I will show you real quick how it changes the effect. And then I'll do the bigger one again just to show you. You can see that with the smaller one, the higher sounds are making them bounce, whereas with the higher sounds with this one, it's getting little to no reaction at all. So if you get the pitch just right, the sprinkles could have bounced around like crazy, or they could have just not moved at all, right? You saw that with the lower notes and with the higher notes. And the reason why the higher notes have less of an effect on a bigger object than the lower notes is because the higher notes are shorter wavelengths. They're a lot closer together, they're a lot more chaotic, and they don't hold their ground as much within the object, aka our saran wrap here. But if we have our bigger wavelengths, aka our lower notes, they hold more impact. And a good way to express this is if I took a blown up balloon and I threw it at you, it would just bounce right off. You wouldn't really feel much of anything. It would just be like, ding, gone, right? Not really much of anything to worry about there. But if I took this honking big bowling ball and I chucked it at you and it hit you in the shoulder, you would feel that. It would probably push you, it would feel painful, it would have an impact, right? It's the same with sound waves. If I threw that tiny little sound wave at you, it didn't have as much of an impact as if I threw a huge sound wave at you. It would hit you harder. You would hear it easier, right? So The way an object will respond to sounds of different pitch is called frequency response, and frequency is measured in hertz, which is basically the number of sound waves that we hear per second. So human hearing typically is between 20 to 20,000 hertz, which is quite a bit, which means that any frequencies or sound waves within that range will hit our eardrums and we will hear it. But if it's an animal, say a dog, their frequencies that they can hear go up to around 45,000 hertz, which is why they can hear dog whistles a really, really high pitch, and we as humans cannot, because it's a higher pitch. It's a higher frequency than what's within our range of hearing. It's too short, it's too light. So if I took something way too light and I threw it at you, you probably wouldn't feel it at all. But if I threw it at that dog, the dog would feel it.